All right. Well, thank you very much. Today's topic that we're covering is extremely important and extremely relevant. This is about how we can harness AI for climate resilience. And if you think about what the world has been focused on for many years with climate change, it's about reducing emissions. And unfortunately, we've not taken enough action. We've not reduced emissions fast enough, and we are starting to see the impacts of climate change again and again and again, whether it's in fires, floods, extreme drought. And I do want to just highlight that I'm on the board of the Woodwell Climate Research Center, which is one of the leading providers of independent climate science, and they can help provide insight into what's coming. These climate models can give you very good insight into what's coming. They may not be able to tell you when, but I'm going to give a specific example. And now we'll go down the list with intros and we'll get into the discussion, but I want to set the stage here. In the beginning of 2020, I was in a board meeting and Dr. Jen Francis gave a talk on polar vortex and how the destabilization of the jet stream would cause it to dip down into Texas and it would sit there for a week or two. And about a year later, that exact thing happened. And the image that was on the Financial Times was basically the same image that was in her presentation. So for the investors in the room, if you want to know what's going to be on the front page of the Financial Times, you probably should get smart about climate and learning about the projections that are coming. And there are many, many tools out there to help you with this. There's great mapping tools. There's all sorts of resources. And unfortunately, that weather system in Texas caused a major, major deep freeze, about $80 to $100 billion of economic loss. There was loss of life. There were companies that went out of business. And there were companies such as energy storage companies that made a lot of money in that situation. So first, let's save lives. Let's understand what's coming and let's adjust our infrastructure and our planning accordingly. But this is a very local problem. Climate, very big, very high level, but you can get this insight at the local level. The challenge is getting people to take action. How do we give everybody accessibility to this information? How do we give everybody the ability of taking action at the local level? I really think that the systems that we've had in place, the old economy, has not been moving fast enough to solve the problem. AI is the only thing that's going to enable people to move fast enough and to move in the right direction. And I'm very happy to have this amazing panel, and I want to give everybody a quick chance to introduce themselves and their companies, and then we'll get into the discussion.
Hi, everyone. My name is Russ Wilcox. I'm CEO and founder of Artifacts AI. In addition to that, I'm a distinguished member of the United States of America's Artificial Intelligence Society and an expert in residence at Boston University. And so Todd highlighted that climate is not only a global issue, it's a local issue. And I'd make the argument that climate is a local issue first, because you can have a top-down approach with policies, as we see with the climate accords, we see with the UN. But in order to get that enacted, it has to be at the local level. And there can be no buy-in. In fact, there could be massive pushback. Secondly, the localities actually have better climate data than anyone in the world. The problem is that they're stuck in paper documents in a PDF on a website, sitting in a state database, and there's no insight to really what is driving the dynamics at these cities. So at Artifacts AI, we've built AI agents that can go to any city in the world, extract all of their public documents, and structure that information into four things: a person, a place, a project, and a policy. And what we do is we do risk management for infrastructure companies, where we can expedite the approval processes for climate-related projects, green energy projects. Secondly, we are building a system that, when aggregated up, can actually provide one key issue that is missing from climate models. What is the human impact? We have now the ability to understand what is the impact at the city level, aggregate that up, and not only find solutions to problems, but identify opportunity zones for changing the way that we invest, how we build, and then also saving the world.
Hi, everyone. I'm Raviv Turner. I'm co-founder and CEO of NatureX RMS. On a nutshell, we let you talk to maps. So imagine a world where you can unlock the hidden insights in satellite imagery and geospatial data using natural language, where emergency responders, where nature conservationists, urban planners can actually talk to maps, where AI agents can actually help you take action on maps in real time. For example, we are in a pilot with Santa Cruz County, where their emergency management team doing work that used to take 2 days and a team of GIS analysts in 2 minutes Another good example is the LA fires, which I get into details later on. But the idea is to democratize access to geospatial data using natural language. Those large language models are not trained on geospatial data, so it takes training. For example, if you want to understand flood, if you want to understand fires, if you want to understand natural disasters, you need to do specific training on geospatial. And the idea is that people that do not have any GIS background can actually interact with maps in real time. So this can work across industries, of course, building climate resiliency, working with Santa Cruz County. In order to unlock federal funds from FEMA, you need to do damage assessment. That damage assessment reports takes close to 3 months to prepare right now with a team of GIS analysts and many, many man hours. It can take probably a matter of days, using our technology. Can be other use cases. Any industry that really runs on geospatial data, from utility management to data centers to urban planning to supply chain risk, of course, to fleet management, can use this technology. Pretty amazing. I was at the Forbes Dome yesterday with a bunch of AI folks, and I'm a big believer in AI for impact and for AI to do good. Yes, it comes with some waste, of course, of energy and water. We talked about it. But I do believe that there are use cases that can justify this. For example, with emergency management, insurance is another case where we can save lives and minimize damage to properties using like the GLLM technology.
Hi, everyone. I'm Jennifer Turlick. I'm practice leader of Climate and Energy AI at the Martin Trust Center for MIT Entrepreneurship. So I build, research, and instruct AI for climate and energy solutions. I built a suite of AI tools that we piloted in the MIT Climate and Energy Ventures class, a class that has historically had about 60 spin-out companies and over $5 billion raised. Just as an example of one of the tools, a suite of policy analysis tools that let entrepreneurs see the relevant regulations and incentives for their business idea, which we actually built in partnership with Artifacts AI. And we heard from one startup that said, hey, I just spent $10,000 on a consultant to try and find this information, and it took them months, but your tool just gave it to me in seconds for free and almost the same information. So how can we build tools like this to accelerate climate entrepreneurship? I also teach a course called AI for Energy Solutions during MIT's IAP term, and we have folks from all over the world from various parts of industry building low-code and no-code AI tools that are impactful for climate and energy. And then finally, I do research on AI applications for energy.
Hi, everybody. My name is Oliver Gottfried. I'm a Breakthrough Energy business fellow. So in my role at Breakthrough Energy, what I'm really focusing on is on helping climate tech startups which are leveraging AI to really optimize their go-to-market, their market segmentation, and their fundraising strategies. So we just realized at Breakthrough, if you are an AI startup operating in climate tech, your business model, your marketing plan, your sales plan, your market segmentation really follows different steps than a traditional hard tech startup. So my role in that organization is really to help startups navigate that new landscape and help them scale very fast so that they can really achieve the impact they want to achieve.
All right. Thank you very much. Good mix of skills and backgrounds in this panel. So the first topic, it's really kind of two questions, and you can take it in whichever direction is most relevant for your experience and background. There's kind of two problems, right? One is, what are the issues? What are the risks, whether it's fire, drought, flooding, what's coming? And where, like what and where, and then how do you get people to take action, right? How do you get people in that community, in that area, to take action? So I think those are the two big things that we really need to accelerate, and we can leverage AI to do that. So I would ask everyone on the panel, how do you think we could leverage AI to address those issues?
Cool. So I think I'm going to take the first question first. But one of the things that scares me the most about the next few years is not the rise in fires. It's not the rise in large-scale storms. It's actually water. I think we're totally underappreciating what, one, the quality of our water is, and two, its availability. And so there's been a strong discussion in the AI community around data centers. First, around their CO2 output. We know they have now surpassed airline travel. But secondly, their just guzzling water. I think for one query for ChatGPT, it's the equivalent of a glass or two of water. Ravi, you might know more than I do. So that presents a big problem. But we also know that AI is going to be ubiquitous in today's society. So can we use AI to actually solve this problem? Well, the data centers don't care about what type of water goes into them. Secondly, there are towns across the world that are dealing with algal blooms that have bad water quality that can't be used and they can't afford to fix it. What if we could use AI to identify those sites that have bad water quality and need a water remediation plant and put a data center there? So one, you're offsetting a carbon sink, i.e. algal blooms that when they die give off nitrous oxide, which is 300 times more potent than CO2, but also cleaning the water around you and finding these opportunity zones with AI. Before, that's not possible, but now using AI, we can go into the specific cities and identify novel use cases around these opportunity zones that would have been missed in the past. And I think that AI is going to be critical in expediting our projects, but also finding new areas to innovate to solve these solutions.
I do want to jump in really quickly. When someone mentions AI and climate, they typically immediately go to the energy consumption and water consumption of the data centers, which is a very valid and real concern. I do want to emphasize that the ability of moving faster, getting people to move quickly in the right direction, I think is going to be the big way of impacting climate in a positive way. And I do want to give two highlights. There was two companies out of the MIT Climate Energy Ventures class, one that helps reduce water consumption for anything that has a cooling tower, and another one that increases the efficiency of compute by drastically reducing energy use at data centers. That one's called IR Labs, and they just raised $150 million. So it's very much a real problem. There are lots of solutions. Efficiency is one of them, and this panel is much more focused on the action at the local communities and building resilience, not necessarily addressing the data center energy consumption and water consumption problem.
Thanks, Todd. So back to building climate resiliency, the three areas: preparedness, response, and recovery. And we'll talk about fires and water as just examples of how can we harness the power of AI. Starting with fires, I live in Boulder, Colorado. Those of you familiar, I don't know if Jason is here. We had the Marshall fires back in 2021, and this wasn't even a forest fire. This was like hurricane speed winds coming down Boulder Canyon, destroying 1,000 homes on a kind of pretty dense urban area. For those of you from the US that know Highway 36, it stopped 1.5 miles south of my house. Our CTO, his house got totally destroyed in that fire, which also triggered an insurance issue, right? He was insured for $700K, took another $1.2 million to rebuild that house. We're seeing the same problem happening right now with the LA fires. So on preparing, if you're following the science behind the LA fires, we had El Nino, right, last year, which means there was a pretty wet winter, lots of vegetation that got out of control, meaning lots of fuel for the fire. We're in a La Nina right now, so historic drought in the LA area, again, fuel for the fires, and the idea of being in a desert area between a low and high pressure systems that triggered what's known as the Santa Ana winds. So when high winds meet fire, I don't know of anything that can pretty much stop it. However, we could use AI to prepare better. For example, we have pre-trained visual models that can identify those dry vegetation to do some mitigation. So mitigation could have been done by harnessing AI and the visual power of working with what's known embeddings in geospatial data to go and mark all those dry vegetation areas for mitigation. We know there are power companies that are getting sued, including in Hawaii, for not doing this work. So this work, this prevention work can be done today using AI and geospatial data. You gave, actually, if you follow me on LinkedIn, there is the story of Brianna. She's PhD in remote sensing. She works for NASA. And for the first day in the LA fire, there were no fire mapping. They couldn't fly the drones because of high winds, which means that they relied on satellites imagery. However, people didn't have access to the satellite imagery. It was chaos as far as evacuation orders, as far as evacuation routes. People that evacuated were in the dark for the first 2-3 days, not even knowing if the house was kind of burned down to the ground. And in order to really follow the updates for that fire, you needed to have like 15 different tabs open on your browser, tapping into kind of homegrown applications. So you would be surprised that it's 2024, 2025 already, and we still don't have access to near real-time satellite imagery and remote sensing insights in order to do emergency response. So huge problem where AI can help. Russ, you mentioned water. We're doing a project on the Mississippi River looking at nitrogen levels, right? And water pollution, again, using geospatial data and analyzing all sorts of indication that we can see from space. It's called passive remote sensing, on looking at the reflection of light on water surface and understanding water pollution. So harmful algae bloom, nitrogen, other pollutants, which means that if we understand water pollution, we can take preventative action working with farmers upstream, again, using AI, using geospatial data. There is, it's called the hypoxia area of the Gulf of Mexico, where it's the size of, I think, New Jersey, and dead zone, and nothing can live there. So this suffocates life of organisms, kill the fishery industry, not to mention causing colon cancer, and huge impact on human health. We can harness the power of AI and visual training in order to see pollution in water these days. So water example.
Yeah, so I think there's a lot of challenges and opportunities when it comes to AI for climate and energy. On the challenge side, AI currently takes up 1 to 2% of our energy mix, but it's projected to grow to 20 to 30%, which is obviously quite substantial. So there's lots of risks, and these are real because right now we're using AI and it's causing definite emissions at the moment. And an emission today costs more to the climate than an emission later down the line. So that's like a real definite thing. On the opportunity side, there's lots of potential opportunities, like the wildfire one mentioned is a great example for adaptation. A mitigation example is in the form of peak shaving or load shifting, where imagine 10 EVs all come home and plug in at the same time in the same neighborhood. That can create a peak load, a spike in energy demand that the grid may not be able to currently handle, which may necessitate expanding the physical infrastructure of the grid, which is expensive and time consuming and may not let us meet our climate goals. But what if we installed AI at that site? So the cars all charge at intelligent times throughout the night and everyone wakes up with their car charged. This would mean we wouldn't have to expand the grid as much. It could lead to installation of further renewables. It could reduce emissions, and it could lead to lower electricity costs for consumers. So I think there's both challenges and opportunities, and I'm sort of looking at an equation. And if anyone's heard of any research in this area, I'd love to hear about it. Of, what's the potential future benefit, which is kind of ambiguous compared to the real cost of leveraging AI at the moment. And in terms of how to get more folks on board, I've been encouraged by some of the results in the course that I'm teaching, where people are using these low-code drag and drop tools across industry to do lots of different things, like detecting whether solar panels are broken or not, and doing renewable energy forecasting and building efficiency optimization.
Well, I'm going to focus on 2 points here. I think, and Raviv already touched upon them. So I think there are 2 AI technologies which are super crucial for the topic Todd mentioned here. And the first one is our physics-informed neural networks. So what Raviv just explained with the desert wastelands, you can do the same with the wind flows. So you can really predict how the wind will turn in the current situation, the current geography. So you can really predict in what kind of direction the fires will go. So this really helps you or helps firefighters respond to that emergency. The second one is advanced simulation. The tool which are used right now in advanced simulation, they're so advanced, they can really predict if it's like wind flows, if it's fire developments to a degree of 98, 99%. So using that kind of tools which are already existent but not available to the firefighters or the fire departments is just essential. And those are just 2 infrastructures which could be easily used. And that really shows the benefit of AI. Unfortunately, and I think this is a huge problem, it's not spread so far. So a lot of like fire departments, but also other state institutions and organizations, are aware of those tools and they don't know how to use them. So I think education in this part is really important. And I think that's where we have to work on in order to leverage AI to its full potential to reduce those kind of situations.
All right, thank you. So we do have to wrap up. I did want to make one comment around accessibility, and it's really important to note that there are a lot of free tools for individuals to use where you can download for free on your own machine, LLMs that you can work with and do your own RAG locally, keeping data private. So while AI has been historically limited to big companies and people with lots of funds, it's now very accessible. So I encourage everybody to learn how to use those tools and to get access to them. I also do want to finish as a reminder. I'm Todd Hines. I'm a co-founder of Climate Scale Up, which is hosting this event, and I'm also the co-CEO and co-founder for Magent, which is a tool that helps build individual AIs that people will own and control to help them thrive in an AI-first world. If anybody wants a demo, I'll be out there for the rest of the afternoon, and you can always snap a picture of the QR code if you want to learn more. So again, thank you very much for joining us on this panel, and I will hand the mic back to Jason J.